Hello, Year 8. I'm here today to talk with you about a serious issue. Whiteboard markers. These things, very important if you go into teaching. They're gold. Don't let anyone take them away from you. Serious stuff. Anyway, I'm holding up a number of whiteboard markers here, and you'll see they are of different colours. In fact, there's a couple of the different brands there. I think I prefer this one, this Stoutler. I don't even know how to say that. I'm not an English teacher, eh? So here we go. What have I got in front of me? I have 2 greens, a purple, 3 reds, and 2 blues. And you know what? That's what we're starting with today. I'm going to write that up on the board. So I have 2 green, 3 red, 2 blue, and 1 purple. By now, I hope you are sitting there in utter confusion because that's exactly what I was doing. We're actually talking about probability. So probability, the chance of different events occurring, absolutely fascinating area. In fact, I once went for a job with a crew that did this stuff for a living, probability of certain things. I was offered the job, but I didn't take it because it involved gambling and it wasn't really my thing. But probability is everything out there. Ever see people buying lotto tickets? What is the probability behind that stuff? I can calculate that. I can tell you probably, well, it's not probably, it's on average, you just wouldn't buy those things. But there's a whole mathematics behind it. They know exactly how much money they're going to get in from you buying a lotto ticket, and they know how much money they're going to give out, and they can calculate all this, and I can calculate this, and hopefully you can calculate this too one day. All about probability. One of my favourite areas of mathematics. I hope you enjoy it too. But today is just a small introduction. There's some concepts that I'm going to introduce to you, and some mathematics of how you calculate it, and hopefully you can go out into the world and not be sucked into gambling. Anyway, so here we go. We're going to use the example of our whiteboard pens here. I'm going to introduce you to some concepts. So I'm going to put a concept here. I think this, I don't think this is such a good one. Art line. It's not as good as a Statler, is it? I mean, that one, those ones tend to work better for me for some reason. Anyway, this one's probably been around a while though. It's probably a bit old. Now we have the concept, we have the theory, and I'm going to give you an example. That's going to make more sense in a moment. I need to introduce you to the concept of trial. Trial is doing something. For example, picking up a whiteboard eraser, whiteboard marker, or flipping a coin, or spinning a spinner, or rolling a dice is the other one that your text will tell you. But in our example, it's picking up a whiteboard marker, right? So, trial, right? It's basically doing something. Well, actually, it's doing something. And the example in this case is picking up a whiteboard marker, right? That's a trial. So the second concept I need to quickly review is sample space. In fact, the text has an error here. I'm looking at the text in the background. That's also why I said something strange before. It's because it's saying an event is a collection of outcomes. That's not right. It's actually sample space. The concept of sample space is a collection of outcomes. Now, in terms of our whiteboard erasers that we were looking at just before, what were the different types we could pick? We had them listed along the top. You could pick a green one, you could pick a red one, you could pick a blue one, or you could pick a purple one. That's essentially your sample space. That's the only things you can pick. Now, in year 10 in particular, they make you use these curly brackets to explain this. In year 8, you can just do a list. The sample space is just, the things you can pick out there. So you could pick out a green, you could pick a red, you could pick a blue, or you could pick a purple. Those brackets are required in year 10. At this moment in time, you'll get away with just listing green, red, blue, purple for something like that. If we were flipping a coin, you'd just list heads or tails. If you're rolling a dice, you'd list 1, 2, 3, 4, 5, 6 for a normal dice. There's all sorts of different dice out there. If you're into particular nerdy games, you'll realise there's a whole lot more out there. And that's an encouragement to participate in nerdy games. Now, next up, what else do we need to do? Probability. So probability is the chance of a particular event happening. Probability ranges in value from 0 to 1. I like to have a good chat about this in class. It's a bit more difficult to do that here. So, may need to refer to your... I've had enough of this whiteboard marker. I'm going to throw it out after this lesson. All right, so probability is essentially from 0 to 1, and it's how likely an event is to happen. Within that, you need to clarify 0 means it's impossible. And I often get students to say, well, what is an event that has a probability of 0? What's something that's just never going to happen? And traditionally what we'll do is go, I know, we'll be abducted by aliens, or the sun won't come up in the morning, or something like that. And then another student will go, hang on, there's like a 0.0000001 chance that'll happen. The sun won't come up in the morning. And you go, whoa, way too deep for us right now, okay? 0, the probability of 0 is something that is impossible. The probability of 1 is something that is certain. And yes, there's all sorts of philosophical arguments you can have with those concepts, but that's not for today. Something that had a probability of 0.5, what do you think that would mean? Well, it would mean it has an even probability. Like flipping a coin, you've got about an even probability that you'll get heads or tails. Right? And from there, you can discuss different probabilities and their possibilities of happening. The important thing is with this unit is the idea of how you calculate probabilities. So generally the probability is calculated. I'm going to have to use the other blue one here. We're doing what you call is theoretical and... See, theoretical probability is what should happen in theory, and we are actually dealing in theory here. We had our 8 whiteboard markers, and I'm asking you a theoretical question. I'm saying, well, if I did pick up a whiteboard marker, what is the probability that I'd get a blue one? And that's theoretical because we're dealing with, in theory, based on that number, what I'd get. What I actually get if I randomly picked up a whiteboard marker could be anything, couldn't it? It's not necessarily going to follow what we'd expect. But theoretical probability, which is the emphasis here, is about, well, what would you expect to happen? So they have formulas like this. The probability of an event is equal to the number of outcomes of your event divided by the total number. There's more detail there in your text if you want it, but for example, what's the probability of selecting a green marker? So if I was to write this formally, and that's one of the things you need to get used to more in year 8, is the idea of writing things in a certain way so that they're very clear. There's a wonderful language of mathematics, And if you use it properly, everyone who is familiar with that language can read it. And it makes a lot more sense than the English language, I promise you. With apologies to my magnificent English teachers back in the day and our wonderful English teachers at our school. Now, probability of green. That's how I'd write the probability of getting a green marker. PR for probability with green in the brackets. That means the probability of getting a green marker. Now, there were 2 green markers there. So that's the number of outcomes that involve the green marker, right? That's number of outcomes. There were 2 green markers out of the total number of outcomes. How many markers did I hold up at the start? 2 plus 3 plus 2 plus 1. It was 8 markers. There's something naughty about that fraction. I hope you notice it. It needs to be simplified, doesn't it? So I'm going to simplify that. The top and the bottom are both divisible by 2. See how 2 goes into both of those numbers? If I divide both by 2, it's actually 1/4. So the probability of me selecting a green marker is 1/4. You could also put that as a decimal if you wanted. I hope you'd recognise at this point that 1/4 is the same. Hey, Anthony.
Yeah.
What's 1/4 as a decimal?
0.25.
Good stuff. Right? So I'm hoping you too recognise that a quarter is 0.25. All right. The last concept that we need to run over, so I'm not going to keep you here all day. It's all right. You will get the perception of freedom yet, is complement. Now, complement, I'm going to get rid of this, but complement is the idea when you've got 2 events that added together have a probability of 1 or of 100%. So they're 2, I'm going to write that a little bit better than that. So if you have event E, they call it, event E dash is the probability that E does not occur. What's 1/4 as a decimal?
I would, 1/4 of that, isn't it 25?
Yeah, 0.25. What's 1/8? Can we go further?
Why? I want to go to year 6.
All right, so here we go. In more practical terms, complement means this. If I said that I had an event that's the probability of getting a green whiteboard marker, the complement of having a green whiteboard marker is not having a green whiteboard marker, because the probability of those 2 events combined is 100%. It's all of the sample space. So if you have an event like getting a green marker, the complement is not getting a green marker, not getting that event, and the 2 of them combined should cover all of your options, all of your sample space. So probability of getting a green marker and not getting a green marker, which is, what did I have in my hand? There we go, that's your green marker and that's not your green marker. You get that the probability of getting a green marker plus not getting your green marker is 1. It's 100%. 1 is 100%. Right? Other examples of complementary events. The probability of it raining plus the probability of it not raining has to add up to 100%. The probability of me giving my children lunch plus the probability of me not giving my children lunch, it has to add to 100%. They're all complementary events. They add together to give 100%. They add together to give all of the events. Now, so in the example I'm going to write here, it's just going to go the probability of green plus the probability of not green equals 1, which is 100%. All right? In the text, they describe it with those letters. Like if you've got an event E, see that little dash there, E dash? That's a probability of not that event. See, I could have written this as green dash with that little dash there. That's the same. That means not green if you ever see that little dash. All right? So opposite events, and they add to get a probability of 1. The total is a probability of 1, which is 100%. Now, what I'm going to do in the next screen is use our whiteboard markers example. I hope I've still got the full 8 here. 3, 5, 7, 8. I'm going to use all our 8 whiteboard markers here from the original example and give you some questions. So it's going to be a very direct, here's a question, here's how we work it out, here's the answer. So that's the theory. Let's now do it in practice. Okay, so let's keep going. Ladies and gentlemen, this is our example that we're going to go through. Now, we've still got our whiteboard markers, our 8 of them, including the purple one I'm about to use. And we're going to answer some probability questions. So remember, there were 2 blue, 3 red, 2 green, and 1 purple. The sample space. The sample space is simply a list of the different outcomes that can happen if I pick one of these. What are the different outcomes that can happen if I pick one of these? What can I get? What colours?
Red, green, or blue.
Or?
Purple.
That's it. So the sample space simply lists that. We can get red, green, blue, or purple. All right, second question. What's the probability of getting a red one?
3 out of 8.
Absolutely correct. There are 3 red ones out of a total of 8. That is the answer for that question. 3 out of 8.
Bye.
See ya. If you want to put that as a decimal, you can. If you know what 3 out of 8 is. Do you know what 1/8 is? You can use a calculator, but if you're going to methods, I'd like you to be able to do that manually. The trick is that 1/4 is 0.25, so 1/8 will be half of that, and you can work out from there for the student who's wanting to do that right now. Now, state the sample space of green with this funny little symbol on it. What does that funny little symbol mean? It means not. This actually means not. So in effect, we want to know what objects are in not green. So what here in our whiteboard markers is not green? It's the other colours, isn't it? So the sample space of not green is everything that's not green. Red, blue, and purple. And from there, the probability of not green, well, how many of them are not green? 3 plus 2 plus 1, 6 of those are not green, are they? 6 of these are not green. So the probability of not green is 6 out of the total of 8. Now I'm hoping you realise, and you need to do this every single time you can. If you can simplify, you need to simplify. What's the common thing there? What can I simplify by? Both of them are divisible by 2. So the probability of not getting a green marker, green whiteboard marker, is 3 out of 4. Those are the sort of things you need to be able to answer. So you need to know sample space is your different outcomes. You need to know probability is going to be, well, the number of times your event occurs divided by the total number of events, right? Total number of outcomes. So number of outcomes that are red divided by total number of outcomes, you get the probability. All right, state what else there? It's all along that line, those lines. Remember that little thing means not. So if you see green with a little apostrophe there, it means not green. So you should be able to state sample space, work out probabilities, number of outcomes that meet your criteria divided by the total number of outcomes. Do it every time. And remember to simplify your fractions. The only other weird thing I need to note in the text is some of them talk about vowels and consonants, which is an English concept that I don't necessarily remember always myself. These are vowels. Vowels are A, E, I, O, U for the purpose of this. Consonants are every other letter. So vowels and consonants refers to letters. Vowels are A, E, I, O, U. Consonants are every other letter. All right, so that is a imperfect rundown of content to do with probability. That's our introduction to probability. Please go forward. If you have any particularly intense and horrific issues, please do message me. You can always do more videos or fix the existing, you never know. Please be in contact. Thank you. Bye.